Okay, I can't start a new thing every day. File open.
सर आपकी पॉलिसी उल्टी पड़ जाएगी।
अरे पढ़ने दो यार, अब जो भी है।
कोई परिचय नहीं आएगा जब उसको पता है 5 नंबर जाएंगे।
All right, so this is what we were doing. इसको करते हैं फिक्स, है ना? So, all right, so क्या क्या कर लिया था हम लोगों ने? कल जो किया इज दैट फाइन विद, सो कल जो किया इज दैट फाइन विद एवरीवन? कोई सवाल? ओके, so then what we do now is, so tell me, once you know what are you going to train on, so you have the training examples, okay, so tell me those 4 lines, so tell me the training loop. क्या ये? Until convergence. So until convergence, and then we replace this with for epoch 1 to whatever number you want. So until convergence, compute j, the cost function, compute grad j, and then update. Okay. What are the things we are missing in this? J. So what do you think should j be for this particular purpose that we are doing? What is it that you should try to maximize or minimize? Given this, we had this equation just. So this equation is super important. We did this for just one word. आपको ये सारे words के लिए करना. So basically you need to generalize this. What is it that you want to maximize or minimize? Maximize probability of, right, output given input. So we have it here. What should j be? नहीं, मेरे को समझाओ क्या है. See, what are we looking for? Maybe I put this aside a bit. What did we compute in the last class? Probability of which word? देखो, there will be so many notations, so many variables ki they will overlap. So W I have been using for parameters, weights, but you should be able to figure out ki which W is. So right now this W is word. Okay, or we can start using just U and V. Yeah, that's a better thing to do. Okay, so what was it? What is the probability of? So wait. So the probability of word output given word input, right? But this is what we saw yesterday. Okay. Now, what will be the numerical value of these probabilities? Of course. What more? So, if you are talking about 10,000 numbers, right, and even if you assume a uniform distribution, every probability is going to be 10 to the power minus 4. All are small numbers. But do you agree that some of them will have high probability and rest of them will have much lower probability? In fact, most of them will have a much lower probability. Okay. So what you do is that, and that might lead to you, so let's say if you do a couple of multiplications of such probabilities, what you are going to do is, you are going to suffer from underflow. So I'll keep some space here. Now this you did for this thing is done for what? We did it for just one pair. How many such pairs were there? 4 billion. Okay. So do you want to maximize this probability? सोच लो आराम से. Do you want to maximize this probability or minimize this probability? Right. So if my training pair is, so what is my training pair? W input comma W output. This is my training pair that I am currently talking about. अपने वो क्या था? अपने example में it was wfox and quick. So what we are looking for is probability of quick given fox should be maximized. Okay, so we maximize this. That was for just one training example. You are supposed to do it for everything. So summation over what to what?
एक बार तो वर्ड जो कि अपन प्रेडिक्ट करते हैं इनपुट देने के बाद एक इनपुट जो लिखना है.
So remember this figure again. This one. For one center word, you are doing it 2k. So if k is your window size, you are doing it for 2k. Okay. Now right. So first summation should go from because there will be a lot of mess related to these variables, because in paper they are choosing it to be C. So I'll try to keep it, try to keep the notation of the paper itself, right? So if C is your window size, then the first summation will be from, so if I am the center word, then C minus 2, C minus 1, myself, no, C plus 1, C plus 2, C is 2. C is 2 if my index is J. If my index is J, then I am talking about J minus C, J minus C plus 1, myself, and then keep on doing this. Okay. So J is this fine? J is myself, right? And I need to exclude this. Okay. and j is not equal to 0. So j is my current index. Right? Is this just this thing? Does this thing make sense? No? No. Okay. So I am at the current center word, label it j equal to 0. Okay. So j is basically labeling for particular window. J equal to 0. Now if c is my window size, I will go all the way from minus c to plus c. So in this summation, how many iterations are going on? 2c plus 1. 2c plus 1 because c this side, c that side and j itself. But again मेरे को वहीं पे जाना पड़ेगा ऊपर. So what was that? Fox, quick, brown, fox नहीं था, jumps over, right? So when fox is my j and you write that equal to 0, तो कहाँ से शुरू हो रहे हो? Minus 2. Okay, so minus 2, minus 1, 0 myself, plus 1 and plus 2. This is all we are saying. Right? But then our variables inside, they don't conform with these things. By these variables j and c should come inside. So what should this thing be now? How should this thing change? So word of j given W0 Wi. Okay, so what should I do here? What should we have? So okay, before I go there, let me try to do something here. So this was for just window. I have kept fox fixed, but I am supposed to do, so ये अपन ने अगर 4 billion से compare करें, so we have done it only 4 times, okay, but I need to run this over complete corpus. So there should be one more summation. What is that? That goes from t equal to 1, the first word, to capital T. What is capital T? Number of words in the corpus. So I start from the first word in the corpus, I go all the way until last word. For every T I do this whole thing. So what should this thing inside be? Given WT, I am looking for does this whole thing make sense? So shall we rewrite this? Summation t equal to 1 to capital T. Is this fine with everyone? This one? But you are starting from the first word in the corpus to last word in the corpus. And then for a given center word, what are you doing? Okay? Or maybe what I can do now is I can write j equal to minus c to c and j not equal to 0. Okay. What else? W T plus J W T. Is this fine? इसको मैक्सिमाइज. Okay. Now, what are these numbers? Probabilities. They are supposed to lie between 0 to 1, and it's a very bad corpus if vocabulary size is only 10,000. Right? We are keeping it 10,000 for the sake of argument, but otherwise you should have somewhere around 50,000 to 100,000 words in your vocabulary. But the sum of these probabilities will still be 1. That means the probability distribution will be such that almost all words, barring a few, will be very, very close to 0. Right? So these numbers are going to be very small. Okay. Now, anyway, so these numbers are going to be very, very small. So what you do is, how do you solve this problem of underflowing or overflowing? So to solve this problem of underflowing, you take log. Now those smaller numbers will not be close to 0 anymore. You actually bring them close, much more representable in binaries. Okay. So your word lengths of CPUs hain, they will not be bottleneck now because numbers are not so small. So this is what we are trying to maximize. Now remember, when we were doing machine learning, we said we don't want aggregate of this, we rather want an average. Okay. So ये फिर से मैक्स उड़ेगा, 1 by T. Okay. So J equal to max of this. P. Thank you. So P. Does this make sense? Okay. Now, see, if you are just doing implementation of things, so somebody must have already thought of for a cost function for you. But if you are trying to do something new, most likely, so if you see machine learning papers in NeurIPS, ICML, everywhere, you see a few kind of papers, right? Some use cost functions earlier, they do improve training and improve results on accuracy and everything. Some will solve a new problem where they are maximizing or minimizing a different cost function and so on, right? But what is the problem with this whole thing? We are going to use gradient descent. What is the problem with this particular cost function? Gradient descent will not take you to max. Gradient descent will take you to minima. So what should this function be? ये max फिर से उड़ेगा. Minus of this whole thing. Okay. So minus of this whole thing, and then So this is the cost function that you can directly put there and keep on doing rest of the things. Any questions here? I'm okay discussing this cost function because so why I tapped my head was because I skipped one step. Right. So if you see, this whole thing actually physically doesn't come that automatically. So what we are supposed to do, what are you trying to maximize or minimize? What are you trying to maximize? Probability of Wt plus j given Wt. You are trying to maximize what? Right. So probability of this right, and this is what you are supposed to maximize. And if you take log of this, this is what you get. What is this thing, by the way? Likelihood. कौन बोला सबसे पहले? कौन बोला likelihood? Right. Good. So this is likelihood. Likelihood of what? You did it for the first time. Probability was high. Then you multiply it with another high probability thing. So if your answers are perfect, will this whole thing be maximized? You start from very first example. So first word, then my next word is, so that pair, you start with this pair. You maximize this probability, right? Then you multiply it with the next probability and so on. So this is the likelihood that you are talking about. Then you take log, you are talking about log likelihood, and then basically it gets converted to summations. So this thing is same as this thing. In fact, this thing is same as this thing if you take log on both sides. Of course, वो 1/t मैं यहाँ पे भूल गया हूँ, so you can do that. Questions here? Fine? All right. So let's go ahead with this now. So J is done. So in this part, if you see, J is done. You can keep on computing J. What else are we supposed to do? Now what is wrong with this? Yes. What is wrong with this? So this is a super important thing. मैं इसको box में नहीं रख रहा हूँ, but you should know how to argue for this. What is wrong with this? Can anything be wrong with this? This is fine, this is summation, this is fine. So the only thing can be wrong with this particular statement. What is this? This is here. Okay. So let us try to rewrite that. Right. Let us try to rewrite this thing. What is it? E2 right. So I won't rewrite that same thing that we did yesterday, right? That's up there. But what will be wrong with this? What may be wrong with this? If your vocabulary size is 100, okay, how many summations will you have in this? How many summations will you have here if your vocabulary size is 100? 100? How many summations will you have here if your vocabulary size is 100k? 100k summations, and this many summations you are doing for just one example in your training. This is super slow, right? Because if you were doing so many operations for a lot of things, fine, but you are doing this expensive operation only for one training example. So this thing is the bottleneck. You are multiplying these 300 numbers here, dot product, this is not going to take time, GPU, fraction of second, I mean, right, it's a GPU, these two things are vectors, it will give you very fast. So this is not a bottleneck, this is not a bottleneck, bottleneck is this summation here. You are going to sum this thing mod V times, where V is the vocabulary size, where mod V is the basically vocabulary size. So you are going to do this summation that many times, and this is bad. This makes your training dead slow, so much slow that the authors report that it was not worth doing it. So the training is so slow that the authors didn't want to do it. Word2vec is not a paper, it's a collection of 5-10 papers. Every section is a paper in itself, right? So then how do you solve it? How do you solve this problem of computational complexity? So there is something called hierarchical softmax. I won't go into this in this class, okay? You can go to my YouTube videos and look at that, because that will be a little bit of digression. All you need to know is there is something called hierarchical softmax. So what that might be doing? See, if you have 10k vocabulary size, okay, so this was our architecture. So here you have 10k, here you have 300, here you have 10k. So softmax will ask you to take a summation over all this. What hierarchical softmax will do is, you divide things into two equal things. So at this stage you are just going to tell me whether the word lies in the upper half or the lower half. So you kind of do a just binary classification whether it belongs to upper half or lower half. That way you have reduced 5000 summations in the very first step. Now let's say it lies in the upper half, okay, in this case it was in the lower half. So let's go for the lower half. What are you going to do now? Upper half of the remaining one or lower half of the remaining one, and then you train. No, you just train. So a lot of times you will be doing it wrong, a lot of times you will be doing it right. Okay. So how many summations you will be doing in this case now? See, you will get some numbers here, but you are going to get those numbers from here. So these things should be set up in such a way that you get it right. I don't want to go into the details of hierarchical softmax. Okay, if you want to go into the details, so I mean I can ask of course कि ये syllabus का part है, go and look at my YouTube videos, but I am not doing that. ठीक है? So what you do is something of this kind. I am not going into details. मैं पहले से बोल रहा हूँ, right? So how many summations are you doing in this case now? Log n. Okay. So much better than n. So log of 100k will be 100 कहाँ कर रहे हो यार, log of 100k क्या बेस ले रहे हो? So log of 100k, if you take base 10, it will be 5, right? So log of 10 to the power 5 base 10 is 5. So very small number compared to the original one. So instead of doing for 10 lakh, you will be doing just for 5 if base is 10, if base is E, you will be doing maybe 15, okay, but no more than that. So this is the idea behind hierarchical softmax, but as all of you have raised some kind of questions on this, they don't finally use this one. What they actually use is something else. So again, this is a very small section in the paper, and in the paper they have nowhere described the neural network architecture. So this is a very cryptic paper. It took me really long to understand what is going on. Okay, so I think I have said everything I wanted to say. Okay, so let's go to next. And this was skip-gram model. Now a little bit about now I'll do it at the end. Once we are done with the whole skip-gram thing, I'll devote some 5-10 minutes to it. Alright, so then let us go to negative sampling. And this is that idea which makes word2vec super powerful. जितने मर्जी है स्टार लगा लो इस कंसेप्ट के पीछे. So that means midterm 1 negative sampling. Okay. So what are we going to do in negative sampling now? What is the, so the story goes like this. You are going to do this summation over, to compute softmax, to compute the probability, you are going to do this summation over the whole vocabulary size mod v, है ना? And then we say you should be able to reduce it to log of mod v if you start using hierarchical softmax. It turns out they don't use it, so they do something else which is negative sampling, and that's what we are going to do now. Okay. I won't be able to finish given this time, so I'll just talk about the idea. Math of it we'll do in the next class. So what they do in negative sampling is the following, and again see, so word2vec, I don't think I have read a paper, more beautiful than this. Every line, every section, I mean, everything written here is so beautiful, so mathematical, so intelligent, that it is beyond. Exactly. So वो जो मैंने कल ट्री भेजा था, if you have seen this explosion के root में you have word2vec. Okay. So now negative sampling goes like this. Remember, when I asked you this question, please give me a glass of question mark. How many candidates are there for this fill in the blanks compared to mod V? Very few. That day we also argued maybe less than 1%, right? So if you already know that there are so many guys who are just not going to appear in here, right, then taking this summation over everything is most likely a overkill, because they are not going to be there anyway. So for every word you are computing something, that's a problem. So what they say is, let us do something more intelligent. They want to get rid of this. This is the biggest idea. They said we don't want to do softmax, we want to reduce this softmax to a collection of sigmoids, because computing sigmoid is easy and you can do this in, and you are not going to do this for everything. We'll come to this, the math of it. So what they say is, instead of taking so what you do is that for every word you sample some k equal to 5 or k equal to 20 randomly from the vocabulary, and you ask this question whether this particular thing is coming from the data set or whether it is not coming from the data set. Is this a binary classification question? So you basically take a pair, and for that pair you are asking this question, does this pair come from my data set? If it is coming from my data set, yes. If it is not coming from my data set, no. Okay. So use sigmoid over this, and what we are going to do is get rid of this softmax thing. So minus, see, this pair will either come from my data set or it will not come from my data set. If it comes from my data set, so basically there are two classes, yes or no. Okay. So we are going to reduce this softmax to this. How do we do this? We do it in the next class. Okay. I can